Hi everyone, my name is Amorita with student ID 2024-32051. In this video, I will explain about my machine learning practicum using the Gaussian knife bias algorithm for breast cancer classification using the cancer.csv dataset. So, let's go to the step. Okay, the first step is about import library, and at the beginning of the program several libraries are imported such as pandas, numpy, matplotlib, seaborn, and sklearn. Pandas is used to process dataset, numpy is used for numerical calculations, matplotlib and seaborn are used for data visualization, while sklearn is used for machine learning process such as data splitting, pre-processing, and knife bias classification. Okay, the next stage is about reading and displaying the dataset. The dataset is read using the read CSV function and then stored in the data variable. And next, the head function is used to display the first 5 rows of the dataset to see the initial structure of data. After that, the program used the info function to display dataset information such as the number of rows, column names, data types, and to check whether there are missing values or not. Okay, next is about displaying basic statistic with the describe function to use the display descriptive statistics such as mean, standard deviation, minimum value, maximum value, and quartiles for each numerical feature. Okay, next we checking the missing values. If the data is null.sum and the result shows that all columns contain 0 missing values, which means the data set is complete. Next, in the pre-processing stage, the ID and unnamed 32 columns are removed using the drop function, and the ID column does not affect classification, while the unnamed 32 column is empty and contains no useful information. And after we removing unused columns, next we selecting numerical features, and the program then selects numerical features using the condition data types not equal to object. And the selecting categorical features using the condition data types equal to object, and in this dataset the categorical feature found is diagnosis. After that, we displaying unique values and categorical features, and the unique values in the diagnosis column are displayed to identify its categories, and the results show 2 categories, which are B or benign and M or malignant. Next, we can encoding categorical data because the machine learning algorithms can only process numerical data, and the diagnosis column is converted into numbers using label encoder. So the B is converted into 0 and is converted into 1. Next is we can creating a correlation heat map using the seaborn, and the heat map is used to see the relationship between features in the dataset. Okay, next is the program also displays a bar chart to show the number of data in each diagnosis category, and this visualizations helps determine whether the data set is balanced or not. Next stage is about separating features and target. So the data is then separated into features and target variables, and variable X is used as the feature data, while the variable Y is used as the prediction target. Okay, next we can splitting training and testing data, and the data set is divided into training data and testing data using train test split. and 80% of the data is used for training and 20% is used for testing. Next, after splitting training and testing data, so we can creating and training the knife bias model with the Gaussian NB function, and then train using the fit function with the training data. Next, after we creating and training the knife bias model, we can making the predictions. The program makes predictions on both training data and testing data using predict function. Calculating training accuracy. So in this stage, with training accuracy is calculated to see how well the model learns to training data patterns. Next, after we calculating training accuracy, the next stage is calculating testing accuracy. So testing accuracy is calculated to measure the model's ability to predict the new data. Next is about displaying the classification report. So the classification report is used to evaluate the model performance in more detail, and the output displays precision, recall, F1 score, and support. So precisions show how accurate the model predictions are. Recall shows the model's ability to identify correct data, while F1 score shows the balance between precision and recall. Next, we're creating the training confusion matrix. So the confusion matrix is created using the heat map to compare actual data and prediction results. So the horizontal axis represents predicted data, while the vertical axis represents actual data. And the last stage is about explaining the confusion matrix testing. So and based on the confusion matrix testing, most of the data appears on the main diagonal, and this shows that the Gaussian knife bias model can perform classification quite well because the number of correct predictions is higher than incorrect predictions. So, in conclusion, the Gaussian knife bias algorithm works well for breast cancer classification and produce high accuracy. So, I think it's enough from me. Thank you for watching and see you in the next video. Bye.